Okay, let's take a look at the transformations review, and then we'll talk about what we should include in our notes. So as I'm working through this, I'll give you some reminders and some things that I think that you should include in your note sheet. Looking at number 1, we have the image of P. What is the image of P? Using the translation xy, and this is in coordinate notation. So I know that the image is after a transformation. So after it's been transformed, find P. Notice there's no prime here, so it's just point P. It will become P prime, and I have 4 choices, and it moves by this. This is coordinate notation. If I wrote this as a vector, it would be -17, 2. So coordinate notation and vector notation mean the same thing. This tells you how it moves on X and how it moves on Y. So I see it's going to subtract 17 from the X value. So I'll write that over here. I have X minus 17, and the X value in this case is 11. And then I have the Y value, -4, and to that I'm adding 2. So 11 minus 17 is -6. -4 plus 2 is -2. So I should see that P prime, again the prime symbol notates that this is the image, it's been transformed, of -6, -2. So A is the correct choice. Looking at number 2, I have points F, G, and H, and they're the vertices of triangle FGH. It asks me to find the vertices, so the corners, of triangle F prime, G prime, H prime by using the vector. So again, as we just talked about above, this is vector notation as opposed to the coordinate notation. So this is telling me that I need to subtract 3 from all the X values and subtract 2 from all the Y values, just like a coordinate, X and Y. So if I take all of these coordinates, F, I'm going to subtract 3 and subtract 2. Subtract 3, subtract 2. Subtract 3, subtract 2. So if I write these down, F prime then becomes 2 take away 3, so that's -1. 5 minus 2 is 3. G prime, 4 take away 3, and 4 take away 2. And H prime, -1, subtract 3. If you still struggle with your negative values and subtraction, go ahead and just put these in the calculator. And I have -1 take away 3 more is -4. And -2 take away 2 more, -4. And then I find the one that matches that, and that appears to be C. Worst case scenario, I could always graph these on a grid, make a little graph, plot my X and Y, plot the coordinates, and then move it by these values and find where the new values are. And then this one, when you look for lines of symmetry, appears to be one there, so that has 2. This one looks like you could cut it down there, here, here, and there. So that's 1, 2, 3, 4. This one looks like it's got 1 there. And this one also has 1. It's a little off there, right about there. Remember, a line of symmetry is just a line of reflection, or it's a fold line, meaning if I folded along this line, I could map one side of the shape right on top of the other. That's symmetry. Okay, so let's take a look at the next set here. Problem number 4. First, I'm asked to tell if it's a reduction or an enlargement. Remember, reduction is smaller, and enlargement is bigger. And then I need the scale factor. And the scale factor, remember, we continue to call it is the multiplier. And it can be found as a ratio of the new compared to the old. You just have to pick a corresponding part. So again, this relies on my knowledge of understanding what's been transformed. So I see W here, which is the coordinate looks like 2, and that's 1, 2, 3, 4, 5, 6. And then I have W prime, which is at 1 and 1, 2, 3. So when I compare these 2 points, I see W to W prime. So I know that the larger one, W here, is the pre-image. That's what came first, the original. And it became W prime, which is the image. It's prime in the image after it's been transformed. So I see that it's definitely gotten smaller. So this is a reduction. And how did it reduce? Well, I just compare corresponding parts. So I labeled the coordinates here of W. Remember, we compare the ratio of new to old. So I can just take 1, the new coordinate, over 2, or 3 over the 6. And it doesn't matter what point I pick. If I did Z down here, I see this is at 0, -1. And I see this one is at 0, -2. So when I compare those points, again, I would have the 1 over the 2. So you'll see these are all the same ratio of 1/2. So that is my scale factor. I just compare new over old. Most common mistake is that this will be flipped. So I always think of we prefer the new over the old. And let's look at the next 2 here. So now we're going to use the scale factor to graph the new image. So remember, scale factor is our multiplier, which means I just multiply by these coordinates. And the easiest way, in this case, I'll just plot the coordinates. So M, I'll just write these over here. M is at -1, 2. N is at 2, 1, 2, 3, 4, 2, 4. And L is at 1, 2, 3, 4, 5, 6. So if I want to find the new coordinates, say M prime, N prime, L prime, all I do is multiply by the scale factor. So I'm going to take all these coordinates, we'll do M as an example, and I'm going to multiply -1 times 2/3. And then I have 2 times 2/3. That's going to give me M prime. So I'll pull up my calculator. And to do that, we'll just say -1 times, and I can just use parentheses, 2 divided by 3. So that's 0.66. What is that as a fraction? I press the math key, enter, enter, -2/3. So there's the x coordinate. Then I have 2 times 2/3. So I'll just plug that in, 2 times 2/3. So that's 1.33. I change it back to a fraction. That's 4/3. And there's my coordinate for M prime. So I'm at -2/3. So that's somewhere between 0 and -1. And then 4/3, somewhere just over 1. So somewhere probably about there. There's M prime. Then I do the same thing to N. N prime will be 2 times 2/3 and 4 times 2/3. And then L prime is 6 times 2/3, 0 times 2/3. And then when I go ahead and calculate these, I get the same thing here. 2 times 2/3 was 4/3. 4 times 2/3 is 8/3. Just do these in your calculator. 6 times 2/3 is 12/3, which is 4. And 0 times 2/3 is still 0. And I'll plot these. So that's 4/3, so that's just over 1 1/3. And up at 8/3, which is almost 3. 1, 2, 3. Somewhere right about there. That's N prime. And then L prime is 4, 0. 1, 2, 3, 4. And I'll go ahead and connect those, and I have my image. So you just multiply by the scale factor. And we'll do the same thing here by 5/2. So I take G. Let me switch back to blue here. G is -2, 2. H is 0, 2, 4, 6, 0, 6. I is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 8, 5. and j, 1, 2, 3, 4, 5, 6, 1. And then to find these, I just multiply by the scale factor. So -2 times 5/2. Let's do that in our calculator. And I just use my parentheses and I put 5 divided by 2. That's 5/2. So that's -5. And I know that 2 times 5/2 would then just be +5. So I'll go ahead, there's 3, 4, 5, 1, 2, 3, 4, 5. So it's somewhere up here. Notice this is 5/2, that's 2.5. So this is an enlargement, getting bigger, it's more than 1. And I do the same thing to h. Well, 0 is always easy, it just stays at 0. And then 6 times 5/2 is 15. So I'll go ahead and plot that at 0. And that was at 6, 7, so that one's way up here somewhere. And then I, 8 times 5/2 is 40/2, that's 20. And then 5 times 5/2 is 25/2. 25/2 is going to be 12.5. And 6 times 5/2 is 15. Again, just do these in your calculator. 6 times 2.5 or 5/2, 15. And then 1 times 5/2 is 5/2. And we'll plot those. So I prime is going to be 20, 12.5. It was at 8.5, so it's way over here and up. And then j prime will be 15, somewhere right about in here, and then 5/2. So somewhere right about in here. And we see that this has also enlarged about 2.5 times. Somewhere about like that. The ones on the test, I'll be sure they will stay within the grid. So looking again, this is a translation problem. Different way to ask it. They want me to find the location of point P under the translation, again in coordinate notation. This is +3 to the x, -2 to the y. So if I take P, when I'm given a graph, it's going to move 1, 2, 3, and then 1, 2. So it looks like it will be right at 2, 0. Those ones are easy when you have the graph because you can just move it. I know it moves to the right on x because it's positive, and down on y because of the negative. So it's always your x, here's the pluses, here's the minuses, and on your y, here's the pluses, here's the minuses. So it gives you the direction and magnitude. Looking at number 8, this is essentially asking it kind of in reverse. We want to know if triangle RST, if r moves to r prime by this vector, what are the other two coordinates going to be? So again, not terribly difficult because I know this is going to move 1, 2, 3, 4, 5, 6, 7, 8. So that's a vector of 8 on x, and then 1, 2, 2 on y. So that's how it moves all my coordinates. So if I take the coordinates, I can move them all in the same vector, or I can just take the actual coordinate listing, so -4 and 1, and then t is 1, 6. And so if I add 8 to this one, s prime, add 8, add 2, add 8, add 2. So this one's going to be 4, 3, and t prime will be 9, 8. So 4, 3, and 9, 8. B is the correct solution. Okay, which transformation of triangle TRS creates triangle T prime R prime S prime shown below? So again, so we're taking TRS and we're moving it over to T prime S prime R prime. So I see that this looks like it is flipped over because now the vertical side here is now on the back side. So that would have to be a reflection. And this is over the y-axis. So it looks like it may be reflected over here. This is 1, 2, 3. So it'll be 1, 2, 3 on this side. 1, 2, 3. So it would be 1, 2, 3 on this side. This is 1 away, so it'd be 1 here. So it looks like if I reflected it, that looks like it's in a good shape, and then it looks like it would have had to slide down 1, 2, 3. So it doesn't have to move right or left, it's already in the correct position, it just needs to slide down 3 units. So that's a reflection across Y, and then a translation down 3. So reflect across Y, and then translate 3 down. Looks like that's the one I want. Now if I can't figure that out, this is multiple choice, so I could always work through the 4 possibilities to see which one does what I need it to. Like if I looked at, say, B here, this one says it translates 4 units right, 3 down. So I just move all these 1, 2, 3, 4, 1, 2, 3. So there's T prime. Is that where it needs to be? No, so I know it can't be B, so I could eliminate that choice. C says reflect across Y and then translate 6 units down. So if I move these, say, pick any point, reflect it over here, and then move it down 1, 2, 3, 4, 5, 6, that'd put T prime right there, which is not where it needs to be, so I've eliminated that choice. So I can always work backwards and eliminate possibilities. Take a look at number 10. We have quadrilateral TU-VW, and it's reflected across X to become T prime, U prime, V prime, W prime. What will be the coordinates of W prime? That's the one they care about. So I don't really have to go through the process, but we will, of reflecting the entire thing. Now this says on X, and I see X right here, so I know that's the horizontal. So it's going to reflect right across the X-axis. So I'll plot all the points. So this is 2 above, so it will be 2 below. There's T prime. This is 2 below, so it becomes 2 above. W prime, 2 below, so it becomes 2 above. Notice I'm not changing it horizontally. It doesn't move left or right, it just reflects on the other side of the line. If I fold it along this line, it would lay right on top of itself. And this is 4 units above, so it will be 4 units below. And there's U prime. So my quadrilateral looks something like that. It's a reflection right over this x-axis. Now what they asked me is where is W prime, and I see W prime, it looks like it's -4, +2. So B is the correct solution. Easy one to make a mistake because they're all very similar, just either a flipping of the x and y coordinates or a change in sign, so be very careful when you're reading your coordinates. This one asks me to draw the figure. I have A, which is 2, 3, so I'll plot and label. B, which is -2, 1. C, which is -1, -3. And D, which is 3, -2. So here's my figure. And we're going to draw the image, so that's after it's been transformed by reflecting across the x-axis. Again, I see my x right here, so I know that is this axis. So I just plot these. This is 1 above, he falls 1 below, B prime. 1, 2, 3 below, so he is now 3 above. There's C prime. A is 3 above, so now it's 3 below, A prime. And D is 2 below, so now it's 2 above. There is D prime. So if I look at it again, here's my quadrilateral after the transformation. And A prime is the coordinate 2, 3. B prime is the coordinate, I'm sorry, that was the original. Look for the red, 2, -3. B prime is -2, -1. C prime is -1, 3. And D prime is 3, 2. Now if you remember, or if you make good notes, what you'll notice is when I reflect over X, the horizontal positioning, A is neither left nor right of where it's plotted, it just fell to the other side of the line. So what happens is I take all these Y's, and we'll notice that when I plot this, 2, 3 becomes 2, -3. -2, 1 becomes -2, -1. this -3 becomes a +3, and this -2 becomes a +2. So the sign of y flips because what was above is now below. What was below is now above. And it's exactly the same when you reflect over y, but the sign of x changes. So same thing here. I'm going to plot the points. A is at 2, 3. Let me go back to blue here. B is -2, 1. C is -1, -3. And 3, -2. So here's my quadrilateral. And we're going to draw the image by translating it using this, again, coordinate notation. In vector form, that would just be 3, -1. I know it's a vector because I have these special brackets that are pointed. Tells me it's a vector. Same thing. So I know I add 3 to the x's, take away 1 to the y's. So that means I move to the right on x and down on y. So I'm going to take all of these. I'm just going to move them 1, 2, 3, 1. There's B prime. 1, 2, 3, down 1. A prime. 1, 2, 3, down 1. 1, 2, 3, down 1. And there is my image. Remember, again, the image is after the transformation. The pre comes before. And I'll go ahead and get those coordinates. Now I can either read them off of the graph here, or I can just take all these, and I know I'm going to add 3 minus 1, plus 3 minus 1, plus 3 minus 1, plus 3 minus 1, because that's how the vector is going to move each of these coordinates. This one's going to become 5, 2, and I'll double check that, and it is indeed 5 up at 2. B is going to become 1, 0, and I see that's right there at 1, 0. C is going to become 2, -4, so 2, -4, that's right where it's at. And then 6, -3. 6 down at -3. And I've plotted those correctly. Let's look at 13 here. This is our first rotation. So I'm going to take these again, 2, 3. Go back to blue for the pre-image. There's A, B, C, D. So there's my quadrilateral, A, B, C, D. And we're going to rotate it 90 degrees. We're going to go counterclockwise. You can go ahead and erase that. They're almost always counterclockwise unless otherwise noted. This one does say clockwise, but I just want you to be able to rotate counter. So I could actually take this entire coordinate grid and turn it a quarter turn in that direction, counterclockwise, and read the new coordinates. Or from my notes, I know that a 90-degree rotation is going to take my XY coordinate and it's going to change it and make it, I'm going to flip these, make it a YX, and this is going to become the opposite sign. So if I take all these coordinates, 2, 3, I'm going to flip them, so that's 3, 2, and then change the sign of the leader. B, I'm going to flip them, so that's 1, -2, and change the sign of the leader. C prime, flip, -3, -1, and then I change the sign. So that's a plus, I'll just delete it. D, I'm going to flip, -2, 3, and then change the sign. So it's positive, I'll delete it. And there's my new coordinates, simple as that. -3, 2. There's A prime. B prime is -1, -2. C prime is 3, -1. And D prime is 2, 3. And there's my new quadrilateral with a 90-degree rotation. Again, if I just rotate my graph paper a quarter turn, or a half turn if it's 180, or 3/4 turn if it's 270, I can match up and find the new coordinates. We're going to do the same thing here, 90 degrees counterclockwise. Take these 4 points. So if I know K is at -2, 2, Again, let me go back to blue for the pre-image. Negative 2, 2. H is 3, 4. R is negative 1, negative 3. And C is 3, negative 1. So again, 90 degrees. I know that XY is going to become flipped and change the sign of the leader. So I flip these. So that's 2, negative 2. Change the sign of the leader. Flip these. Change the sign of the leader. Flip these. Change the sign of the leader. Flip these. Change the sign of the leader. I'll just delete the pluses. And there's my new coordinates. And we'll go down here to 270. Very similar to the 90. When I go 270, my XY is going to become, they still flip, but now I change the sign of the follower. And we'll get these coordinates. So C is 4, 1. L is 3, negative 3. And T is 1, 2, 3, 4, 5, 5, negative 4. So again, I flip these. This one becomes 1, 4. Change the sign of the end, the guy that's following. Flip, change the sign. Flip, change the sign. Simple as that. And last one here. Enlarge to 150. So to do that, I'm going to go ahead and take the coordinates A, B, C. So A is 2, 2. B, it looks like, is 1, 2, 3, 4, and up at 2, 4, 6. Whoops, 4, 6. And then C, it looks like, is 2, 4, 6, 6, 2. Now 150%. A prime, B prime, C prime. I know that this is 150%, so that is my scale factor or ratio. So that's 1.5. So if you think of a percent as a decimal, you just move this 2 places back, and that's 1.5. So that is your scale factor, your multiplier. So I multiply all these by 1.5. Again, we can just use our calculator to do that. So I have 2 times 1.5 is 3. So there's my new coordinate. 4 times 1.5 is 6. 6 times 1.5, so 6, 9. And then 6, this one became 9, and then 2 became the 3. And then I'll plot those. So 3, 3. There's A prime. B is 6, 9. There's B prime. And then C is 9, 3. 6, 7, 8, 9, and 3. And there's my new shape. Dilated 150%. It's bigger than 100 or bigger than 1, so I knew it was an enlargement. And it tells me right there. And to change percent to a decimal, I just move it 2 places to the left. Any questions, we'll go over on Monday, and I'll help you create your note sheet, put everything on there that I think you need to have to be prepared for the test on Tuesday.